how to write the equation of a horizontal asymptote of an exponential function. So remember how to write the equation of a horizontal line. A horizontal line will always have an equation y equals some number, where that number represents the y-coordinate of all the points that are on the line. So for example, the horizontal line that passes through the points 2, 5, and negative 2, 5 will be y equals 5, because notice that y equals 5 for every point that's on the line. So what we can do is we can use this idea to describe the asymptotes of exponential functions. So an exponential function in the form f of x equals ab to the x will approach 0 from above or below, but will never actually reach it or cross 0. So that's why the asymptote of this function will be the x-axis, which has the equation y equals 0. So for example, if we look at y equals 2x, right? So in this case, b equals 2. Notice that it gets really close to the x-axis, but it won't actually intersect it or cross it. So it has an asymptote at y equals 0, which is the x-axis. So this is true of any exponential function that has the form y equals a times b to the x. Okay, so it doesn't matter if you have a negative 3 to the x. Notice that it's going to get really close to 0, but it's never going to cross it. Okay, it doesn't matter if b is 1/3. Notice that this is going to once again approach the x-axis but not actually cross it. Same thing if we have negative 1/4 to the x. Okay, so it's going to get really close to the x-axis but not actually cross or intersect it. So if we have an asymptote of an exponential function that's in the form y equals a b to the x plus k, it's going to have a horizontal asymptote at the line y equals k. Okay, so the difference here is that before we had y equals ab to the x, okay, and then here we have y equals ab to the x plus k. Okay, so if there's a number being added onto the end of the exponential function, that number is going to give you the horizontal asymptote. So for example, we have y equals 2 to the x plus 3, so that is going to have a horizontal asymptote at y equals 3. Okay, and notice that that's what the graph is telling us. Notice that this graph gets really close to y equals 3, but it doesn't actually intersect or cross that line. So, it doesn't matter if we have different forms. So if we have 3 to the x plus 4, that's going to have an asymptote at y equals 4. If it's 3 to the x minus 5, it's going to have an asymptote at y equals negative 5. So let's determine the horizontal asymptote of the function g of x equals 3 times 1/2 to the x plus 2. Okay, so notice that this is in the form y equals ab to the x plus k. So that means that y equals k is going to be the asymptote. So that means that y equals 2 will be the horizontal asymptote of this function. So now you can go ahead and pause the video and try this example on your own. So this function is y equals ab to the x form. So in this form, the horizontal asymptote is always going to be y equals 0. So this function is going to approach the x-axis but not actually cross it or intersect it. So by looking at the equation of an exponential function, you can go ahead and determine where the horizontal asymptote is. If the function is in y equals ab to the x form, the horizontal asymptote is the x-axis. If the function is in y equals ab to the x plus k form, the horizontal asymptote is the line y equals k. Remember in this first one, when it's y equals ab to the x, that horizontal asymptote is y equals 0, right? Because that is the equation of the x-axis.